Hello everyone and welcome to Lab 7 in this course. In this lab I am going to configure summarization in OSPF. So we are going to use the same lab scenario that we were using it in the previous lab, lab number 6. And then we will add on it something and then we will do the summarization, and we have to follow all those points that you can see here in front of you. We have 8 points here and we go one by one to be able to finish our lab. So let's now see what is the lab diagram that we're going to work on. As I said, we are going to use the same lab scenario that we were using in the previous lab. But what I've done here, I have just added, as you can see here, I have added some bridge interfaces. Okay, and on each of the bridge interface I have put an IP address. Okay, so there is networks here which are 172.16.0.0. That's on bridge 2, which is 172.16.0.6, I think the IP is. And then bridge 3 has 1.0. So all those networks has been added, or all those IP addresses actually in the bridge have been added on this lab, because we are going to make the summarization in a moment when we do the lab for all those IP addresses. Okay, so let's go now and see what we have to do in this lab. Point number 1, we are still using the same lab scenario of lab 6. That's something we have just seen it now. Point number 2, bridge interfaces and IP addresses have been added on router 6 as per the graph. So also that's something we said that we have done it, and if you want to check it, we can go to router 6 here, and you can see here inside router 6 I have the bridge interfaces that I have created them. Actually, those interfaces are representing network, okay? Because I don't have many networks because I'm using GNS3, and I don't want to make a real lab environment and I connect APC on each router. So I'm using GNS3, and then to emulate a network, I can use a bridge, okay? A bridge interface is just like an interface. It has an IP address, which is a network actually. Okay, so I'm here using the bridge interfaces. We have 2, 3, 4, 5, 6, 7, 8, and 9. That's what I have created. And then here we have the IP addresses. So you can see from bridge 2 onward, 3, 4, 5, 6 are the IP addresses which are in the graph. So actually the best to do is to put here the picture of the graph, so we can also see what's happening. So these are the IP addresses of the bridges that I have created on router 6. Okay, point number 3, they're asking us to advertise the new networks of router 6 that we have created on the bridge interfaces on OSPF. So we have to advertise those networks on OSPF. I go to router 6 now, and remember router 6 is inside the area 1. Okay, so we have to advertise those interfaces inside area 1. We go to routing OSPF, and then here I will go to networks, and then actually what I can do, instead of advertising one by one, I can put everything, because router 6 is inside area 1. It's not connected to any other area. So I say all interfaces to be on area 1. Okay, so that's what we needed to do. Then this point is done. Check if router 1 is getting the routing information about the new networks of router 6. Because we have advertised here all those networks inside OSPF, and everything you have now here OSPF, then in this case router 1 as well as any other routers like router 2, 5 and so forth, also on area 2, they should get the updates about those networks. So let's say they ask us to check about router 1. Let's go to router 1 now, and then from router 1 I will go to routing OSPF routes, and then you can see here those networks have been shown. Okay, we can see 2.0, 3, 4, 5, 6, 7, 8, and then here is 1.0. All right, so everything now looks good. So router 1 is receiving all those networks, and if you want, we can see also here the LSAs, they are here, but also if we look to IP route, and then we can see that router 1 is receiving all those in his routing table. You can see them here. Okay, then point number 4 is good. Point number 5, make the best summarization calculation of the networks of router 6. What is the summary address? Before we do this, let me just go back to router 1 and show you something. If we go to router 1 here and we go to IP routes, as we have seen that each of the networks of the router 6 is having an entry inside each of the routers in the OSPF that we have here on this lab. And if you look here on router 1 inside the routing table, you can see that it has an entry for each of the networks that are on router 6. 172.16.1.0, 2, 3, 4.0, 5.0, 6.0, 7, and 8. Okay, so in this case, the routing table of the router 1 is becoming big. That means it will use more memory for networks which are coming from the same router. So what if we can do something like a summarization to make like a summary address of all or some of these addresses in order to have less entries inside the routing table of router 1. When I say router 1, I'm also saying the other routers on OSPF, okay? Because the other routers also will have the same entries like in router 1 now. So this is what we need to do now. We need to make a summary address to be like a summary for all those networks, or maybe to the most possible addresses of these networks that we have here. Okay, and this is what they're asking us to do in point number 5. Make the best summarization calculation for the networks of router 6. And they're asking what is the best summary address that we can use. Now we need to play a little bit with the binary and the decimal address to be able to get the summary address. Okay, so we've seen that we have the networks 172.16.1.0/24, huh? And 172.16.2.0, 3.0, 4.0, 5.0, 6.0, 7.0, and 8.0. That's the networks that we have on router 6. And all are 172.16, okay? And they have a /24, that's class C. Okay, now, if we remember about the decimal and binary conversion, we have to start by putting first 1, 2, 4, 8, 16, 32, 64, 128. Okay, now if we look here, we see that the first 2 octet from here 172.16 are the same, so we are not going to make anything on the first 2 octet. What is changing is the 3rd octet here, 1, 2, 3, 4, 5, 6, and so forth. So from here, this octet is the change happening. So let's take this octet over here, the 3rd octet, and let's convert it from the decimal as it is here to binary, because from there we can get the summary address. Okay, so 1 in binary is 1, because that's here 1, we need 1, and then we don't need the rest, so we put zeros on the rest. 2 is 1 and the rest are zeros. 3 is 1, 1. 2 plus 1 equals 3, correct? We put 1, 1 and the rest are zeros. So we have done 1, 2, 3. Now 4 is 1, 0, 0, and the rest also 0. 5 is 4 plus 1 equals 5. Okay, and the rest is 0. 6, 4 plus 2 equals 6. Rest is 0. 7 is 4 plus 2, that's 6 plus 1, that's 7, and the rest is 0. And then 8 is 1, and the rest is 0. That's 8. Okay. Now, if we want to look here, we can see that the change, if we look here, is happening mostly from here. Okay, you see the rest here is 0, 0, all are zeros here. Only the number 8, which is 172.16.8, we have a 1 here. That's why I can say, let's do the summary only from 1 to 7, and then 8 we don't do summary for it. So when you do a summary address from 1 to 7, then all those addresses here, all those networks will be represented by one network only, is the summary address. And 8 on top will be shown also. So in this case, instead of having 8 networks inside the routing table of router 1, we will have 2 only addresses. The summary address, which is from representing the network from 1 to 7, and the address of network 172.16.8.0. So this one will also be shown in the router table. Okay, so the best to do, I will take out this. Okay, so let me take this out, and then we do now the summary address of the first 7 networks. Okay, how to do the summary address? We have to look first where the networks that are not changing. We look here and we see that this one here, the line, we can drag it from here like this. Okay, because we can see over here that all here are zeros, so they are not changing. What is changing is only the last 3 bits of this octet. Okay, in this case, we can get the summary address. Okay, now how to do that? We said that the subnet mask here is /24. That means it is 255.255.255.0. When we do the summary address, the subnet mask will be changed. Okay, but before we talk about the subnet mask, let's first get the network ID or the summary ID of the 7 networks we have here. So we look first to the first octet. 172.16 have not been changed, so we write them 172.16. Okay, so we know now the first octet of the summary address. We still have 2 other octets. Okay, the third octet is where the change is happening. Now we look here and we see that those are not changing, the first 5 bits. Okay, I'll put here 5, and then the last 3 bits are being changed. Okay, so that means that what is not changing has to go inside the network ID. Okay, in this case, we have here the subnet mask 255, because those are not changing, 255. And then here, we see that all of those are zeros, then this is here .0, and the rest is the host, then is 0. Okay, so this is the summary address that we have, 172.16.0.0, and the subnet mask will be, if we look here, it is /24. We said /24. That means we have on the subnet mask here 8 bits plus 8 bits plus 8 bits plus 0. 8 plus 8, 16 plus 8, that's 24. Now, the subnet mask here, after we did the summary, is not the same, because the 8 bits here are not totally now used, because 5 of them are still with the network and 3 of them, they go to the host. Okay, then in this case we have 8 plus 8 plus 5, okay, because those are going also to the network. So 8 plus 8 plus 5, that give us 16 plus 5 /21. Okay, so the new subnet mask will be /21 and not /24. And /21 is 248 and then .0. Okay, if we want also to calculate them, we said that those are here going to the network, the first 5 bits, the 128 plus 64, 192 plus 32, 224 plus 16, 240 plus 8, 248. So this would be our summary address, 172.16.0.0, and this is the subnet mask. Okay, but in MikroTik you cannot put the subnet mask, so you have to put /21. So now we know what is the summary address that we need to use in order to make a summary for all those networks. So this summary address over here is a summary for the networks which are from 1 to 7. Okay, so point number 5 is done. We know now it is 172.16.0.0/21. Point number 6, apply the summary so router 1 and all other routers outside the area 1 can get the summary address. And then they're asking where you will apply the summary address. So if you go here back to this diagram here, we know now that we need to put the summary address as 172.16.0.0/21. And they're asking us, where do you want to add the summary address? So how can we do that? How can we make the summary so other routers on the OSPF receive this summary address for the first 7 networks that we were working on? And here I can say that on OSPF, you can only apply the summary address on the ABRs, full stop. Okay? If you make it on this router here, it will not work, because the ABR is the only router which can make the summary address. Okay, this only happens on the ABR. And here Router 5 is the ABR that we need to apply on it, the summary address, because router 5 is connected to area 1, so connect to router 6, and is connected to area 0. Okay, so let's go directly and do it on router 5. So this is router 5. It's very simple. All you need to do, you have to go to routing, OSPF, and here you go to area range. Okay, before I do it, I just want to show you again, we are on router 1 now, and I'm on IP routes, and I'm still getting all those networks here. Okay, from 1 to 8. Now I will go to router 5. We said inside area range, and then I say plus, and here I have to say in area 1 I want to, and here I put the summary address that we just calculated now, 0/21. Okay, and okay, let's go directly to router 1, and here we go. You can see that all those networks that were showing from 1 to 7 are now suppressed by this network ID, or this network 172.16.00/21, and still 8.0 is shown because it was not inside our summary address. Okay, so router 1 directly now have 2 entries instead of having all other entries. So this point is done. Point number 7, check if router 1 is getting the summary address. We just checked it and it's getting the summary address. And the last point, check if router 1 can reach all the networks of router 6 by using the ping command. So I will go to router 1 now, and from here I will go to new terminals and I say ping 172.16.1.6. That's the IP address of the bridge which is on the network 172.16.1.0. Okay, so we have a reply. We can also try on 172.16.2.6, and also we have a reply. 3.6, that's okay, and then if you want also 8.6 because that's outside our summary, and that's fine. Okay, this point also, point number 8, it's done, and like this we have already finished the lab of the summarization on OSPF. So remember, you have first to make the calculation of the summarization as we have done, and then we have to apply the summarization only on the ABR, and then this ABR will propagate the summary address to the routers inside the backbone area and to other areas if we have. And then in this case, instead of having the list of all the networks inside our routing tables of the routers in OSPF, we will have a summary address which takes a lot of load less on the routers as per the memory. So I hope that this lab was good for you, and I hope you enjoyed it, and I will see you in the upcoming